All right, so in this video, we're going to take a look at how to solve a problem on solution concentrations. Out here, we are introducing the concept of molarity. So a solution is given to us. So a lab technician needs to prepare 250 ml of a 0.50 molar. So this M out here stands for molar. And molar, I'm just going to draw a line out here. That capital M is the concentration in molar, also known as molarity, which is equal to moles per liter. So that's a unit of concentration. And the technician needs to prepare 250 ml of that solution. It's a sodium chloride solution, so that's the molecule that's going to go into solution. And the question is, how many grams of sodium chloride must be dissolved in water to make the solution? Okay, so first of all, we need to understand what exactly is molarity. So molarity is equal to number of moles N over the volume in liters. So that N is number of moles, and that is volume in liters of solution. All right, so to do this problem, excuse me, the first thing we need to do is to calculate based on the molarity given to us and the volume given to us, we need to calculate the number of moles. So let's go ahead and write that formula out here. M is equal to N over V, and then rearrange the formula because we want to solve for N out here. So we rearrange the formula. So by multiplying V on both sides, so we get N is equal to V times M. Now M is already given to us out here, but notice carefully the volume that's given to us is in milliliters, and as per the definition we need liters of solution. So the first thing we need to do is change the milliliters to liters. So let's go ahead and do that. So we can just go ahead and write that out here. 250 ml, to change it to liters, we need to multiply that by a conversion factor, which is, so turns out if you look up a table, it's a 1000 ml is equal to 1 liter. So we put 1 liter on top because we're solving for liters, and we put 1000 ml below. And that way the ml cancels out, and then this simplifies to 0.250 liters. So there you have it. So now let's go ahead and plug these values in. So we plug the 0.250 ml out here, 0.250, sorry, not ml, liters out here. And then let's go ahead and plug the 0.50 molar instead of the M. So that's 0.50. And now you can, to make sure we have our units correct, go ahead and replace the capital M out here with moles per liter. So moles over liters. And that is going to come out to be the solution, which is N is equal to 0.125 liters cancels out, moles. Okay, so there you have it. See, we have moles. Now the question is how many grams. So the next thing we need to do is convert the grams to moles. Convert moles to grams. So to convert moles to grams, we need the molar mass. When you go from moles, if you want to go to grams, you want to multiply with the molar mass. Okay, so let's go ahead and do that. To multiply with the molar mass, we need to first calculate the molar mass. So the molar mass of NaCl is going to be the atomic mass of Na, which is I believe 22.99 plus the atomic mass of chlorine, which is 35.43, and that gives us 58.42 grams per mole. Okay, so now let's go ahead and apply the formula. Moles times the molar mass is equal to grams. Okay, so we're going to take the moles out here, that number 0.125 moles times the molar mass, which is 58.42 grams over mole, which gives us, notice carefully, the moles cancel out, and we just have to multiply those together to give us 7.3025. That's what my calculator says, grams. Now, we need to correct for significant figures. So if you look at the problem, in the problem we have two significant figures out here and another two out here, okay? And we didn't do any addition or subtraction. We just did multiplication and division with the exception of the addition out here for the molar mass. So either way though, if you kind of follow the trail from the beginning to the end, you will actually end up having to express your answer with two significant figures. So we can round this answer to 7.3 grams and call it a day. And there you have it. I hope that made sense. Thank you for watching.